Temperature regulating glass represents an innovative approach to solving the critical issues of energy efficiency, environmental sustainability, and the quality of the internal comfort perceived by occupants. Windows in buildings are accountable for 25 to 30% of heating and cooling energy consumption, contributing up to 40% of global energy consumption and 36% of CO2 emissions by the building sector. This inefficiency necessitates additional compensation through HVAC systems. These have very high operations costs and put extra burdens on your power grids, especially under extreme weather conditions. State-of-the-art solutions like low emissivity glass and static coatings provide limited thermal control only, not to mention dynamic adjustments with varying weather conditions. Because of this, they are ineffective in preventing overheating in the summer. Besides energy wasting, poor temperature control affects health and productivity as well. Extreme heat is estimated to cost the U.S. economy $100 billion annually in lost labor and productivity, while cold weather causes 20,000 excess deaths annually in the EU. Temperature-regulated glass solves this problem by dynamically managing solar heat gains and thermal loss, hence reducing HVAC energy consumptions by up to 30%. This indeed reduces energy costs, drops CO2 emissions, and improves indoor comfort. Meeting these challenges, temperature-controlling glass provides a new solution for sustainable energy consumption, environmental protection, and improvement in living and working conditions.
This is why we're introducing StellaShield, an innovative solution to temperature regulation mentored by Dr. Wang from Cambridge University.
Hi, I am William, the group leader of our project, and I am also the one who is in charge of technology. Now, let me explain to you briefly about what is StellaShield, how does it work, and what can it do.
Using photonic crystals to regulate temperature is utilizing the mechanism of radiative cooling, a process that involves the emission of thermal energy in the form of infrared radiation to the surroundings to cool down. In our design, the glass is made up of two layers of regular glass with a layer of one-dimensional photonic crystals enclosed in a layer of penipum water gel, a thermal-responsive polymer, in the middle. The penipum photonic crystal complex is infused with water such that the water gel can absorb water, expand, and function normally. As environmental temperature changes, the distance between photonic crystals will subsequently change due to the expansion and contraction of water gel, leading to a change in the wavelength that the glass is able to reflect. When the temperature is below 25 degrees Celsius, the glass appears clear as infrared radiation that it reflects is not within the visible light spectrum. However, when the temperature rises to around 25 degrees Celsius, the glass changes to blue color, signifying that the glass is now reflecting high-energy blue light in the visible light spectrum. The change in color shows that the glass is effective at keeping the internal temperature stable as environmental temperature goes beyond 25 degrees Celsius.
Additionally, we have a pending research publication titled The Use of Penipum Water Gel in Photonic Crystal in Achieving Radiative Cooling, expected to be published later in the year. Apart from the current challenge, we're also participating in Environment Challenge, New Science, and Science Fair.
Hello, this is Alan. Our glass delivers a groundbreaking, cost-effective solution designed for construction companies and real estate developers involved in renovation and new builds. Fully compliant with LEED and BREEAM standards, it seamlessly combines sustainability, functionality, and aesthetic appeal. The global green building material market is forecasted to hit $511.2 billion. Focusing on high-demand regions like the US, Europe, and parts of Asia, we have identified a $15.3 billion annually serviceable market. Within 5 years, our target is to secure 1% of this, equating to $153 million annually. By addressing the unique needs of our stakeholders, we are uniquely positioned to drive impactful change in the green building materials sector.
Our temperature-regulating glass, StellaShield, currently costs around $3,500 per square foot in lab conditions. With mass production, costs will drop significantly by adopting industrial standard processes and removing lab-specific expenses, while materials like sulfuric acid and dehydrated ethanol are costly, so industrial efficiencies will help minimize expenses. In year one, we project a 13% profit margin, assuming merely 5 households purchase 8 windows of 3x4 squares each, which is 500 units. By year 5, optimized production could grow this to 55%. We need $15,000 to advance our project, including prototyping, testing, and marketing. We've secured $7,500 from One Carmel and DLUS Family Office, with plans to raise the remaining $7,500 through grants, crowdfunding, and angel investors. StellaShield isn't just a product, it's a revolution in sustainable living, offering beauty, innovation, and efficiency to green building.